Hello everyone. In this video I want to show you some examples of fossils, specimens, things that can be dated using one of the Quaternary Geochronology methods that we talked about, that we covered in the lecture videos about Quaternary Geochronology. Okay, so here are some examples of Quaternary specimens, things that can be dated directly using one of the Quaternary Geochronology methods, others that are more challenging that would require indirect dating, maybe using some of the age equivalent methods or relative dating methods and so on. So we'll talk about the different contexts. So starting with the younger one. So these are mollusks, nice fossils. Now they're slightly overexposed. So let me see if I do this, maybe you can see them a little better. Hopefully the webcam will sort of focus. Yeah, it's not too bad, I think. So these are Iatella arctica. They're fossils of specimens that like to live in cold Arctic waters. And so you can find them today in the Arctic Ocean, but you can also find them a lot in glacial marine deposits from the last deglaciation. So some of the post-glacial seas that existed around the Laurentide ice sheet. These ones come from Southampton Island in northern Hudson Bay. So this is a place that had a post-glacial sea that is called the Tyrell Sea. And so the Tyrell Sea was larger, more extensive than Hudson Bay. And so Southampton Island, part of Southampton Island was underwater during the glaciation because of the crust being depressed due to glacial loading. So soon after the glaciation, the land was still depressed and it got under marine waters. Some lowland areas around the island were below marine limits. So these fossils were retrieved from an esker on the lowland. So top of the esker is about 70 to 80 meters high, and so that esker was underwater for some time and was colonized by these mollusks. And then as land was rebounding a little faster, at a faster rate than sea level was rising, so at some point it was catching up and it became exposed. And so now you find these things, these sites at about 70 to 80 meters in elevation above modern sea level. And so the esker was for some time underwater, and so you can find marine fossils on it. And during the rebound, it became into shallower and shallower water, and so sublittoral environments, some reworking and beach deposits. And then with the wave and movement of sediments, these things all got mixed and with the gravel and sand. And so you can find these scattered throughout the top of the esker over there. And so these ones date just a few thousand, they're just a few thousand years old, and they can be directly dated using the radiocarbon method and using, the best estimate for the reservoir offset for northern Hudson Bay, and so on. You can get a fairly good age estimate for this. And then so moving on to this other set of samples here. So again, like there are a couple of glacial marine post-glacial seas around the Laurentide ice sheet. So there was another one that invaded the St. Lawrence lowlands. So downstream of Kingston, around the Montreal region, there was an inland sea for some time that's called the Champlain Sea. So a lot of the deposits around Montreal at the surface are marine deposits, either clay or sublittoral deposits. And in these sediments, you can find a lot of fossils. You can find things like this really nice gastropod, very well preserved gastropod specimen. And this one is about 10,000 years old. And then there's another one here that is broken, but it's still in pretty decent shape. And then there's some other species like Mia arenaria, like this, another mollusk, another type of mollusks. And And you find the same species as the one I showed you on from Southampton Island. So that's another example of Viatella arctica. So that's another nice example from the Champlain Sea. Champlain Sea fossil record is quite spectacular. In some excavations in Montreal, in downtown Montreal, or sometimes farmers around the Montreal region will also find them, but you can, some full specimens like skeletons of belugas and seals were found in Champlain Sea deposits. Some of them are exposed in museums like the Redpath Museum at McGill University. Some really spectacular fossils from that post-glacial sea, the Champlain Sea. So moving on, so between Montreal and Quebec City, there are some samples, there are some units that are quite similar to the ones we saw in the virtual field trip around Woodstock. So there are some units of interglacial age in that area. So if you remember the Quaternary framework, that's about 125,000 years ago, the climate optimum. So it gives you an idea that anything around that time, the last interglaciation, too old for the radiocarbon method. So this one cannot be directly dated by the radiocarbon method, but it's still a nice fossil. You see the wood is compressed a little bit, so it's flattened, and that's because the area was there was an ice advance after that, of course. So during the last glaciation, it got compressed by the weight of the ice. So all the peat is compressed, and the twigs and pieces of woods are all sort of flattened. But also the age of the material. One thing that's noticeable here is that anything that's old, like organic and pieces of wood like this, that's old, will turn darker. We'll acquire a darker color over time. So it turns dark brown to blackish like this. So when you see this, this is an indication that you're looking at something old here. Okay, so this is not directly datable, but if you find a unit sandwiched in between some other units like sandy units, things like that. Some of these units might be datable with methods like luminescence dating, for example. So if you can get bracket ages, then you can estimate the age of peat, even if it's too old for radiocarbon method, right? So that's an example of an indirect way of constraining a particular deposit, right? Now moving to the western side of Canada, there's this area that's very spectacular for quaternary fossils in northern Yukon. So you see these specimens here. I won't grab that one too much. It's very fragile, but I can take the small one here. So look at this. This is a pine cone, very, very well preserved, and it's not compressed at all. It's still in pretty good shape. So you might think, wow, this looks really young, except the color, as I said, when you see something that's dark like this, it's almost black, this is an indication that it's old. And this one was retrieved from the base of a very thick quaternary sequence that is thought to represent most of the quaternary. And so that was retrieved from the lowermost unit in a braided river deposit. So this cone could be as old as 2 million years old, okay, something around that time. There's a paleomagnetic unit above this that's that show reverse polarity. Okay, so it's definitely older than 800,000 years, but it could be as old as 2 million years. Okay, so very old, and yet it's not compressed. Why? Well, again, if you go back to the Quaternary Framework lecture videos, you'll see the Laurentide, the North American ice sheet complex at the time of the last glacial maximum, and you'll see that northern Yukon is one area that escaped the glaciation, so it wasn't covered by ice, by thick ice. And so units like braided river deposits that are really hard to compress to begin with, yes, they're overlain by lots of sediments, but they weren't compressed, they weren't pushed down more by glacial weight. And so fossils like this were preserved in almost their pristine, original shape. So it's very nice. But this one, again, obviously cannot be dated by radiocarbon method because it's way too old. As I said, you can get ages for overlying units and using other methods like the age equivalent methods like paleomagnetism, things like that. Another unit that is above this is contained Tephra layers. So there's a tephra there in northern Yukon. It's called the Old Crow tephra. It's very well known tephra layer. It's an excellent marker bed. So there was an eruption in Alaska that brought this dust of ash, volcanic ash, across Alaska in northern Yukon and deposited in many places this tephra. So it's a very excellent marker bed that you can find in many different quaternary sections. And so this was data. First of all, it's got like unique geochemistry, so it's got a lot of indicators that you can use. Uh, but it was also dated several times using the fish and track method. And so its age changed with the progress with fish and track, and more recently it's been established to be around 131,000 years, and it's located just below interglacial sediments. So nice tephra, another marker bed. So you've got a tephra layer there, you've got reverse polarity, lacustrine sediments, and then below all that you've got this very old unit with some, there are even tree trunks with roots and like growth position buried in that braided river deposit. So it was probably during like flooding or intense discharge events that flooded some forest and buried those trees. So it's a very spectacular area. It's an all same section also contains like mammoth teeth and things like that, and deer antlers or antlers from quaternary extinct species. So northern Yukon is fantastic for fossils and dating, geochronology, and so on. So anyways, a couple of examples, as I said, of things that can be dated directly or indirectly using different methods that we talked about in lecture. And finally, the last thing, now back in the east again, so this one is from the Appalachians and valleys in the Appalachians that contain glacial lacustrine sediments, so varved sequences. And so some layers, again, if you remember the vars, like that laminated sediment with coarser grain layers, laminations, and finer grain laminations. And so groundwater is allowed to flow. There's higher horizontal hydraulic conductivity, so water will flow along the coarser laminations, and it's slow flow and it's rich in carbonate, so it's oversaturated. In some places, because of changes in temperature and pressure, the carbonate, the calcite precipitate around some nucleus and it forms concretions. So you can find these concretions in those varves, and so this is one example. Really nice, looks like a water droplet, right? You might see might be able to see some layers in there as well, right? So this could possibly be dated using methods of the uranium disequilibrium series methods like the thorium-uranium dating method, if this was good enough for a closed geochemical system, as we talked about, okay? Now you wouldn't get the age of the glacial lake deposit necessarily, but you could get a minimum age for the deposit, but knowing that this is post-depositional, right? So this is important to understand that. But anyways, this is another thing that can be dated using some of the methods that we talked about in class, okay? So that's it. That's what I wanted to show you. So I thought it would be good for you to see some real, get a good visual examples of things that can be dated using quaternary dating methods. So I hope you enjoyed this. You learned a few things, and thanks for watching.